Hello everyone. This is the other new movie that I make in order to continue our chapter 5. Yes, we already watched or learned uh, the first part or part 1 of chapter 5. That part 1 chapter 5 for cover of definition of probability, the approach or the techniques or the concepts that we use in order to study probability of one event or study probabilities of something that will be happening. Okay, so this is the second part of chapter 5. The last slide for previous movie is this one, and yes, I hope that you already practice cell review 5.1 and 5.2 and all those, and you will have some ideas in order to solve the exercise as a homework on this page. Okay, now we will go to new points of chapter 5. Some rules for probability. Some rules for probability. So we have two main rules for study probabilities. The first, rules of addition, and the second, rules of multiplication. But first we will look at or we will learn rules of addition. Addition, that means plus. Okay? When talking about addition, it's about plus. Suppose that we have two events. Two events are mutually exclusive. Okay, two events are mutually exclusive. So what does it mean, two mutually exclusive events? Two mutually exclusive events refer to any two events that cannot happen at the same time. Okay, at the same time, these two events cannot happen at the same time. Maybe only it is only one event coming, so the other event not coming. Okay, two mutually exclusive events refer to any events that only one event come and the other one cannot, or only one event happen, the other event cannot at the same time, or at one time is only one coming or only one happening, the other one cannot come or cannot be happening. Okay, that's why this is two mutually exclusive. So maybe I can give you two mutually exclusive events. For example, in the class, I choose one student randomly. What does it mean randomly? I don't know in advance who is this student. In the class, I choose one student from the class. I don't know this student in advance. It means that I don't know this student is male or female. So student in the class should be male and female together in the class. But if I select only one student, I don't know whether this student male or female. Okay, so suppose male is one event, female is the other events. That's why male events and female events are mutually exclusive. In the class, the result of choosing male student and the result of choosing female student are mutually exclusive events, because if I select one student, if this student is male, you see, male happen, female cannot happen, because I select only one student. If this student is male, so this student cannot be female. Okay, so at the same time, male and female cannot come. at the same time at the same condition, or at one time at one condition, male outcome or male events, female outcome or female event cannot happen at the same time. So that's why we call in the class choosing one student, male outcome and female outcome are mutually exclusive events. Okay, so rules of addition we also divided by sub 3 rules. The first, special rule of addition. So this is we have 3 rules of addition. We have divided into sub 3 rule. The first here, special rule of addition. The second here, complement rule of addition. The third here, general rule of addition. Okay, so under rules of addition this rule can be subdivided into the other 3 rules. One, or the first, special rule. Second, complement rule. Third, a general rule. Okay, so now looking at the first, special rule of addition. To study the special rule of addition, we need to have at least 2 events. At least 2 events. Because addition it means plus. So in order to make a plus, we need to have 2 things. One here or one here. That's why one plus the other one. If you have only one thing and we don't have the other thing, we cannot add, we cannot plus. That's why we cannot make a plus, or we cannot make addition. So at least in order to study rule or special rule of addition, at least you have 2 events. Suppose that we have A event and B event. If 2 events A and B are mutually exclusive, I just explained the earlier here, mutually exclusive. If 2 events A and B are mutually exclusive, the probability of one or the other event occurring equal to the sum of their probabilities. It means if I have event A and event B are mutually exclusive, if I want to find the probabilities of A, one is A and the other one is B, we use or B. Okay, this is or B. So equal to the sum. What does it mean, the sum? Plus the sum of their probabilities of A, their probability, and probabilities of B, their probability. Okay, this is special rule. In order to study special rule of addition, you need to have at least 2 events or 2 outcomes, that these 2 events or 2 outcomes are mutually exclusive. So the probabilities of one event or the other one equal to the sum of their probabilities together. Okay, this is a formula. That's why probabilities of one of A or B equal to the sum. This is the sum of probability A and B together. In case of 3 events, because I say at least 2, that means start from 2, at least you have 2. It means at the lowest number of events, 2, 3, 4, 5, 6. That's why in case of we have 2 events. In case of we have 3 events are mutually exclusive. So the formula it should be like this one. The probabilities of A or B or C equal to probabilities of A plus probabilities of B plus probabilities of C. And you may ask how to find probabilities of A and how to find probabilities of B. This is based on the approach that we watched or we learned from previous movie. Okay, it depends on approach. Whether probabilities of A or B, it is a classical probability or empirical probabilities or subjective probability. So see, this picture we call Venn diagram. So Venn diagram is the picture that shows you the probabilities of two events. So in this case, for this one, we have two events, event A and B separately. If A coming, B cannot come. That's why A and B are mutually exclusive. Or if B coming, A cannot come. That's why A and B are mutually exclusive events. If we have three cases, if A coming, B and C cannot come. Okay, B and C cannot come. If B coming, A and C cannot come. If C coming, B and A cannot come. That's why A, B, C are mutually exclusive events. Okay, so look at this clearly. This is the Venn diagram that shows you two events are mutually exclusive. This is Venn diagram that shows you three mutually exclusive events. Okay, again, in order to start this special rule addition, we need to have at least two events that are mutually exclusive. Okay, you can go to your textbook on page 153. Yes, you can see example here. So study this example by your own time. Okay, this study example by your own time. So I think you must study the example in order to be clear in terms of special rule addition. For this is three events, A, B and C, three events. Okay, this is a solution. Yeah, this is solution. This is Venn diagram for three mutually exclusive. Okay. So Venn diagram is about English logical J-Venn. English J-Venn. He developed a diagram to display graphically the outcome of an experiment. Okay, now we already watched or learned special rule addition. How about second rule? Second rule of addition is complement rule of addition. What does it mean, complement? Complement in order to complete. Okay, complement means that in order to complete. Complete that means 100%. It is used to determine the probabilities an event occurring by subtracting the probabilities of event not occurring from 1. Okay, it is used to determine the probabilities of event occurring by subtracting that means by minus. the probabilities of event not occurring. So normally we have probability that occur and we have probabilities that not occurring. That's why probabilities are occur plus probability are not occur must equal to 100%, equal to the whole probabilities 1. If probability A is if PA the probabilities are even A, so P minus A or P not A, this is not even A. This one mean that not even A, not A. Okay, not even A, not A. If PA is the probabilities of event A, while P not A is the probabilities of not even A. So the probabilities of A plus probability of not even A equal to 1. 1 is mean 100%. That's why in order to find probabilities of A, you need to take 1 minus the probability of not A. Okay, that's why it's here. In order to define the probability of one event happening, A is happening. If A happening beside A, we classify as not happen. That's why not A. Okay, not A. What does it mean not A? Not A, it could be B or C or D or something, or maybe B and C and D and something. Okay, not A. So beside A, we classify all the events beside A as not A. Okay, so this is a definition. We take 1 subtract from 1. Take 1 subtract not A not A. If we want to find properties of A, we take 1 minus property of not A. That's why this is complement. A complement with not A equal to 1. A complement with not A equal to 1. That's why in order to find property of A, we take 1 minus property of not A. If we're talking about Venn diagram, or when we see Venn diagram, this is probability of A beside A not A. So probability of A plus probability of not A equal to 100%, equal to 1. Okay, now we're going to study example on page 155 your textbook and cell review 5.3 on 155. That is one. This is example. This is solution. And this is a cell review 5.3. So we have a table, data table for you, and question A, A1, A2, question B, question 3. Okay. So this is for you to practice. So study example and practice cell review 5.3. Okay, the last rule of addition is general rule of addition. In order to study general rule of addition for probability, at least we have two probabilities. At least we have two events or two outcomes. Suppose A and B. If outcome or event A and B are two events that are not mutually, What does mean not mutually? That means A and B could come at the same time. Okay, for special rule, at least we have two events that these two events are not mutually exclusive. Not mutually exclusive, what does it mean? It means that and even B could happen at the same time or at one time. then the probability of A or B is given by the following formula. This one. So probabilities of A or B equal to probabilities of A plus probabilities of B minus probabilities of A and B. Okay, why we need to minus? Because we don't want, our purpose is want to find probabilities of A or B. Okay, probabilities of A or B. That's why we don't want to see probability A and B together. So take A probabilities of A and B together away in order to find probability of A or B. So special rule is different from general rule. Special rule, A and B are mutually exclusive. That's why we don't have this part. Okay, special rule addition, if we have A and B are mutually exclusive, that's why we don't have A and B at the same time, happen at the same time. However, general rule, we have A and B are not mutually exclusive event. If A and B are not mutually exclusive events, sometimes A and B could come at the same time or at one time. For example, this one. This one is a condition. This one is a condition, or is the time that A and B happen at the same time. Okay, but why we need to take minus? Why we need to take the probabilities of A and B away? Because we want to find probabilities of A or B. A or B, or it means plus. Okay, or it means plus, A or B. So when we're talking about Venn diagram, this area is probabilities of A, this area is probability of B. That's why A and B have some overlaps area, or we have overlaps area, or we have common areas. Okay, common area, they have the same area. That's why this both happen. A and this area means both A and B happen at the same time. But what we want is A or B. That's why we want to study probabilities of A, or probabilities of B. How about A and B? A and B we will take off because we don't want to see A and B. We want to see A or B. Okay, this is what we call general rule. Based on general rule, we have common area or overlap area between A and B. That's why we want to find these probabilities. What does it mean, probability A and B? Probability A and B we call joint probability. You see, based on Venn diagram, A join with B, join together with B. That's why you see we call joint probabilities. Joint probability is a probability that measures the likelihood or the chance of two or more events will happen concurrently or parallelly. Or at the same time. That means both two or more events will happen at the same time, or concurrently or parallelly. Okay, that's why this is called joint probability. This is called joint probabilities. Maybe I just put a shortcut JP, joint probability, because A and B join together. Okay, now we study based on a rule or special rule addition. We have one example. For example, we conduct a survey by asking foreign tourists who came to visit Cambodia during the year. Okay, during the year, maybe a holiday or maybe festival days. Based on this survey, we found that we survey on 200 foreign tourists who visited Cambodia during the year. The survey revealed, or the way showed that, or the way presented that among 200 foreign tourists, 120 they went to visit Angkor Wat site. The other 80 they went to enjoy beach swimming a big time. That means Sihanouk Wheel Beach. And among 200 foreign tourists, 50 they went to visit both places or both sides. Okay, so this we ask the survey asking 200 foreign tourists who came to visit Cambodia. Among these 200 foreign tourists, 120 they went to visit Angkor Wat. 80 the rest, because we have 200, 120 went to Angkor Wat, and the rest foreign tourists went to swim or went to enjoy with beach or sea at Sihanouk Wheel. However, 50 among all this one, they said that they went to both sides of both places. Okay, question: what is the probability a selected person, a selected foreign tourist, a selected person or selected foreign tourist visited either Angkor Wat or Sihanouk Wheel Beach? Either Angkor Wat or Sihanouk Wheel Beach. Only one place. What is probability that we select randomly foreign tourist, a foreign tourist, he or she went to only one place, Angkor Wat or Sihanouk Wheel Beach. Okay, that's why based on our formula, we need to find probabilities of one foreign tourist go or went to visit Angkor Wat or visit beach. That's why it comes from the probabilities of Angkor Wat plus probability of beach minus probabilities of Angkor Wat and beach together. So in this case, yes, 120 over 200. This is probabilities of foreign tourists go to visit Angkor Wat. 80 over 200. This is probabilities of foreign tourists went to a beach, and we need to minus number of foreign tourists or probabilities of foreign tourists that went to visit two places or two sites. That's why we found that one. What does it mean? It means that among 200 foreign tourists, if we select one randomly, we don't know in advance. If we select one randomly, and this foreign tourist said that he or she went to visit Angkor Wat or went to visit Sihanouk Wheel Beach, so we will found that 75% that we get this foreign tourist. Okay, 75% of chance that we select one foreign tourist among 200 that we got he or she went to only one place, not both places. Okay, that's why again probabilities are A or A and B. Probability A and B will be called joint probabilities. The probabilities are two overlap events. Okay, two overlaps event. This is two overlaps or two overlap event or two overlap area. Based on the graph, this is overlap area, but based on event, is two overlaps event. For example, probability A or B. Probability of A and B. The probabilities are Disney or Bush. This is based on textbook. Okay, this is a Venn diagram. So this is a joint probability. This is a joint probability. You can see A joined with B. You can see Disney joined with Bush. Okay, this is we call joint probability. This is we call joint probability. What is joint probability? This here. This is a definition. Okay, now going to your textbook on page 157 and cell review 5.4 158 and exercise 158 159. We can go to 157 first. You can see example here. It also has solution for you. Okay, study this one clearly in order to get clear understanding. Yes, this is the answer. You have textbook, that's why I don't show you for long. You can check your own textbook. This is cell review 5.4. You have two questions to answer, A and B. Okay, continue to our homework. You need to do number 12, number 14, number 18, number 20, number 22. Okay, so continue from previous movie homework. This movie homework will be number 12, number 14, number 18, no 16, number 18, number 20, and number 22. Okay, so I finished my movie by this time, so let you watch and study.